All right, we're going to go ahead and move into our next presentation, and Yolanda is here with us in person. She's going to talk to us about, we've heard a lot about truck parking issues in the last day and a half, and so she's going to talk about some of the work she's doing in that area using ELD data in the process of assessing those truck parking needs. Yolanda has 25 years of professional and research experience in the areas of freight planning, freight policy, and environmental planning, and is responsible for identifying and conducting research of state and national significance. And she is a senior research scientist with Texas A&M. Welcome, Yolanda.
Thank you, Brenda, for that introduction. Let me just say that after traveling for 16 months between my kitchen, my bedroom, and my dining room, I was super excited to attend this conference in person today to share with you some information about a recently completed FMCSA study. Before I delve into our approach and the findings of our study, I want to take a few minutes just to recognize my colleagues that worked with me on this study, as well as Bettina Conroy and Brian Rothier of the FMCSA, who provided direction and guidance throughout the project. So, what were we trying to do? The objective of our study was to explore the use of ELD data to develop a framework for assessing truck parking needs, inform truck parking policy, and to provide information to state DOTs to prioritize investments in rest areas and facilities. But more specifically, the questions that we were trying to answer were, when and where do trucks park because of hours of service requirements? Where are unauthorized truck parking clusters relative to truck parking facilities? What are the sizes of these unauthorized clusters along corridors? What's the capacity of truck parking facilities relative to these unauthorized clusters? And if the nearest truck parking facility was full, where is the alternative or the next truck parking facility relative to the unauthorized cluster? So in developing this framework, we, in consultation with FMCSA, selected 2 corridors that met certain criteria. We were looking for corridors that traversed states with known truck parking issues in terms of truck parking issues reported to the FHWA. We were interested in corridors that went through what we called freight states. These were states that have a major freight gateway, either a marine port or a land port of entry. We were looking for corridors that traversed states with large urban consumption centers, corridors that traversed rural states, as well as, of course, corridors for which we actually had data available. Finally, we settled on 2 corridors, the I35 Corridor, starting in Laredo, that moves through Texas, Oklahoma, and then finally Kansas City, as well as the I-90 Corridor that started in Seattle, and we included the segment that basically ended on the border with Montana and Wyoming. The 3 data sources we analyzed and compiled for developing this needs assessment framework was the ELD data. We partnered with eRoads. We also used the FHWA's HPMS data for the roadway geometry because we were looking for a consistent data source across all the states that were included in this framework. And then truck parking facility information, we basically started off with the American Truck Parking Database and a database that we've developed for Texas specifically. But a huge part of this effort, we had a number of graduate students just driving these corridors using Google Earth and then zooming in on each of these facilities to verify the truck parking information in these data sources. The ELD data that we obtained covered a period of 1 year, April 1, 2018 to March 31st, 2019. We focused on trucks that were stopping for more than 30 minutes because of hour of service requirements, and we identified all clusters within a buffer zone of 1 kilometer from the center line of these corridors. So this provided us with access to truck parking clusters, 380 along I35 and 276 along I90. And so here I just want to make the point that this needs assessment framework consisted of a number of data analytics dashboards that we used and that we developed to visualize the data to answer the questions that I raised earlier on in this presentation. So the rest of my presentation, I'm going to focus on the results of the I35 corridor. Along this I35 corridor, at least the segments that we included in our study, we identified 215 truck parking facilities with a capacity of just over 9,000 truck parking spaces. The average distance between these truck parking facilities is about 5.5 miles. But if you look on the map, of course, in urban areas, the density of these facilities are larger than in rural areas. So the darker segments on the map, that's where the distance between these facilities are longer. Of the 380 clusters that we received information for, about 16% of that sample was trucks parking in unauthorized locations. So just to clarify, these are clusters on ramps to and from I-35, on the frontage roads, on the shoulders of the main lanes, or also on the entrance and exits to rest area facilities. The average size of these clusters were relatively small, 1.2 trucks, but in the dashboards that I will demonstrate shortly, you will see that the size of these clusters vary by month. And then the average distance, and I thought this was very surprising, the average distance between these unauthorized clusters and the nearest truck parking facility was less than 5 miles. So this actually provides a link to the actual data analytics dashboards that we've developed. But I have come to learn that if you rely on technology, something is going to go wrong. So I'm going to show you a couple of screenshots, and then at the end of the presentation, if there's interest, I can actually demonstrate the interactiveness of these data analytics dashboards. So this dashboard, we've developed, this slide actually contains an error on it. I took the screenshot before the dashboard loaded completely, but it just gives us an idea of the market or the geographic reach of trucks that stopped along the I-35 corridor. So it was just an interesting piece of analysis that the data allowed us to do. This dashboard shows the arrivals of trucks along the I35 corridor. And what you can see here is it does show the temporal distribution in terms of the number of trucks arriving at these clusters by day, by hour in the day, as well as by month. So we see this kind of peak in March and April. But what was really interesting was this statistic here that provided us with insight as to how long trucks that are stopping in unauthorized locations, how long they're actually stopping at these locations. And what we found was that 64% of truck drivers that stops in these unauthorized locations stops for on average 2 hours or less, which definitely demonstrated the need for short-term parking. This dashboard provides us with information about the clusters, the number of clusters, and again, along the I-35 corridor, and it shows the distribution by day of week, by hour, and by month. And what's interesting about this dashboard, it shows that the number of clusters are relatively constant. It's just the size of the clusters that varies. And it does point to some of the comments of yesterday also, that these drivers have a favorite spot where they tend to park. Now, maybe the only other thing that I should mention about these dashboards, which is kind of missing from this PowerPoint, is that they are completely interactive. You can filter the data in terms of direction, in terms of the hour, in terms of the category, whether the truck is parking on the shoulders or on the ramps or wherever. You can even drill into these individual clusters, and the temporal distribution shows on the figures. This one I'm going to skip in the sake of time. This dashboard answers a lot of the questions that I've mentioned in the start of the presentation. This dashboard allows you to select a cluster, and I don't know if you can see it, but that is an unauthorized cluster that I've highlighted for the sake of this presentation. In the actual dashboard, if you hover over the dot, it would show you where this truck is parked. It would be in that specific cluster, I believe, is a ramp to and from I-35. The user can specify the maximum driving distance from that cluster. In this case, we specified 60 miles. And then the middle map provides the available truck parking facilities in a distance north and southbound from that cluster within 60 miles. So the actual dashboard, if you hover over these dots in the middle, it does provide you with the distance from that cluster as well as the number of truck parking spaces at those facilities. And then basically the tables on the right just provide you with a summary statistics. I just showed you the I-35 example, but we've developed similar dashboards also for I-90, and we saw some very interesting differences between the I-90 and the I-35 corridor. Both in terms of the number and percentages of unauthorized truck parking clusters along these corridors. In the case of the I-90 corridor, 34% of the clusters were unauthorized locations, were in unauthorized locations versus 16% in the case of I-35. We also saw a difference in the size of the clusters, unauthorized truck parking clusters, the average size. Again, I-90 was slightly higher than I-35 in where these unauthorized clusters are, in the temporal distribution of these clusters. So we see in the size of these clusters. So in the case of the I-35 corridor, we saw more trucks parked in these unauthorized clusters in March and April. Along I-90, it was April, May, and June. We saw a difference in the distance between the clusters and the nearest truck parking facilities. As I mentioned, in the case of I-35, it was slightly below 5 miles. In the case of I-90, it was more than 10 miles. And then finally, we saw a difference in the average time stopped at these clusters. In the case of I-90, about 80% of the drivers that stopped in an unauthorized location stopped for 2 hours or less. So our research did highlight the need for short-term parking. So in terms of future research, our research did, as I mentioned, indicate the need for short-term parking in addition to long-term parking. As we interviewed stakeholders during the course of our research, a few stakeholders pointed us to the emerging pay-to-park business model, and I think how far this model has actually penetrated the industry and how this will impact truck parking moving forward. And then the last point that I want to mention is, in these data analytics dashboards, we could provide information about the capacity of the truck parking facilities, but we had actually no information about the use of the truck parking facility. So if a driver, for example, drove 13.61 miles to a facility where there is 4 spaces, by the time he arrives there, there may not be 4 spaces available. So this use of truck parking capacity by time of day, day of week or month is an area that needs further research. So with that, I think I'm on time, Brenda.
Pretty close. Thank you, Yolanda. Really great information here. Dustin, I think I saw a couple of questions come online.
Yes, the first one. Has there been analysis if the unauthorized clusters have risen since the reduction of the authorized parking areas? For example, the reduction of rest areas.
No, this study was done at a specific point in time based on the information that we've had available over the year. So we did not look at what's happening if the number of spaces at these facilities reduce.
Next question was regarding truck parking needs. Are you doing any research on East Coast corridors, since these highways have been historically the routes with the least amount of truck parking?
So, that was a factor that was considered in the selection of the corridor. We discussed the northeast corridors quite intensively because of that issue. But we ultimately did not include northeast corridors in our analysis because we did not have adequate data, ELD data specifically. So,
do we have any questions in the room?
We do have another one here. Many trucking companies are instructing drivers not to park at many facilities due to PDO events while trying to park at these facilities. Do you think that some of the cluster behavior could be attributed to company policies regarding parking in these facilities?
You know, I cannot answer that question. You know, it's not something that we specifically targeted or even asked in our study. Our study focused on where trucks are stopping because of hours of service requirements. And so, you know, when these are trucks that had to stop because they reached their hours of service requirements. So I don't think that influenced the results of our study, but I cannot say for sure, basically.
One more question. What was the source for the ELD data?
We worked with eRoad. It's a ELD vendor, and we worked with them to get access to the ELD data.
Curious what your timeframes were from when you started your data to when you ended collecting it. What was the time frame?
So our time frame, I'll just slip back to this slide. This was the period that we covered, March 1, 2018 to March 31st, 2019.
Great, thanks again. Any other questions? All right, thanks, Yolanda. Appreciate it.
Thank you very much.